So the last thing that I want to talk about is we have been talking about these transformations where A can be like a rotation, a reflection, or a dilation. But like, can it be more than one at the same time? O sea, like, I want A, for example, to represent um, a rotation by 45 degrees counterclockwise. And I also want A to be a dilation by a factor of 2. So I want these two things to happen at the same time. How could I like code these two things into only one matrix? Well, I know that, for example, this one is a matrix that is cosine of 45, negative sine of 45, sine of 45, cosine of 45, ¿no? O sea, this matrix is, and I actually know these numbers, the matrix that corresponds to this rotation is the square root of 2 over 2, negative square root of 2 over 2, square root of 2 over 2, square root of 2 over 2, ¿no? O sea, this matrix rotates by 45 degrees. But I would like it, o sea, you also know that, for example, what matrix is a dilation by a factor of 2? A matrix that is a dilation by a factor of 2 is 2, 0, 0, 2. Okay, so how could I combine them so that I do both transformations, so that I do like the composition of the transformations? Well, a way of doing it is it depends on the order, because it is not the same to rotate and then dilate than to dilate and then rotate. It is not the same to reflect and then rotate than to rotate and then reflect. O sea, like, transformations have an order and we need to specify. O sea, I think that for this particular two examples, it is the same, but it is not the same when I mix rotations with reflections. So we need to be very like specific about the order. So if I want to do this one first and this one second, the transformation A, that is square root of 2 over 2, square root of 2 over 2, negative square root of 2 over 2, square root of 2 over 2, times 2002. This one represents, o sea, let me put it like this. AXY. O sea, this transformation, what multiplications do you do first? You first do this multiplication, and the result of this multiplication, you apply it to this one. O sea, this multiplication comes first. So first, you rotate 45 degrees, and then you dilate by k equals 2. If you do this matrix multiplication, and let us do it, o sea, the result, I think that you can imagine what is the result going to be, no? O sea, think, what is the result going to be? No, I'm just going to tell you what the result is going to be. Like, the result is going to be square root of 2, negative square root of 2, square root of 2, square root of 2. O sea, if you combine these two matrices, this matrix is the matrix that this matrix represented the transformation first rotate, then dilate. That is what this transformation is. So once that we have understood what individual transformation is, we can combine them. for example, if you look at this one, this is a sequence of, o sea, this is geometry. O sea, this is a sequence of transformations. In this sequence of transformations, what is this? The first one. This one is a rotation counterclockwise by 90 degrees. And this one we've done it 1,000 times. O sea, this one we've done it like 1,000 times. That is a reflection by 63 degrees, no? Or something like that. Yeah, I think that this is a reflection by y equals 2x. O sea, sorry. I hope that I am not wrong, that this is a reflection by y equals 2x. So if you multiply these matrices, this resultant matrix is the transformation that represents first rotate, then, o sea, rotate by theta equal 90 degrees counterclockwise, then reflect by line y equals 2x. So I am not gonna ask you to go from here to here. I am only gonna give you the sequence of transformations, and you need to give me the final matrix. Which is, o sea, the only thing that you need to remember is that they go like in a backward order. O sea, this one comes first, then this one comes second. That is the only thing that you need to remember. O sea, for example, in here, AB, if I do A first, o sea, if I put them backwardsly, it would be the reflection first and then the rotation. That is the only thing that you need to do. That the order represent, o sea, it goes backwardly. O sea, you read like this, but the order goes like that. And that's it. Those are the basic skills from matrix transformations. Now we can do the problems. Woo, math!